Unit 3. I know my mole math like I know my own mind. You will never find a way to make me leave you behind. That's really high. You can't sing that high. That's okay. That's something for all you Hamilton fans out there. We're on to Unit 3. This is about moles and math. But before we talk about moles, we're going to do some math. So I guess really more about math and moles. It's whatever. Let's start with scientific notation. We're back to stuff you should know from middle school, but we're going to review it. When numbers are really large, like 6022 atoms, or too small, like 0.00000002309 meters, it's easier to write the numbers in scientific notation using powers of 10. So numbers like this up here becomes 6.02 times 10 to the 23rd, 6.022, times 10 to the 23rd, where you have a coefficient times 10 to raised to some exponent power. The coefficient should always be between 1 and 10. So whatever that little front number right there is, that's called your coefficient. That should always be a number between 1 and 10. If it's not between 1 and 10, then you wrote your scientific notation wrong. It's like a literal rule of scientific notation. So you can change standard notation numbers, meaning basically normal numbers, from standard notation to scientific notation. The way to do that is to move the decimal point. If you start with a number greater than 1, like this example, 324,170, then that is going to end up as a number with a positive exponent when it's in scientific notation. And to move the decimal, we just keep moving the decimal to make a coefficient between 1 and 10. So if we're starting with 324,000 and we think about like, which way do I need to move the decimal? Well, if I'm trying to make this look like a number between 1 and 10, and I start moving the decimal this way, I'm getting further away from that range of 1 to 10. Right, if I move the decimal like whoop, 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 that's getting further and further away. That's getting a bigger and bigger number that's getting away from 10. So I'm gonna want to move it this way where I can see the decimal, like when I move it here, instead of 324,170, I now have 32,417. When I move it here, I've made it 3,241. When I move it here, I've made it 324. When I move it here, I've made it 32.4. That's still not quite between 1 and 10, but when I move it one more time now, 3.2417, that's a number between 1 and 10. And because we move it 5 times to get there, that tells me to make the exponent not just a positive exponent, which we already knew it should be positive because we started with a large number, but specifically a positive 5. So our new coefficient is the 3.2417 we made when we moved the decimal. And then our exponent becomes a positive 5 because we moved it 5 times. This also works when you start with a decimal number that is less than 1, but that's going to give you a negative exponent. So right away, if I look at this example right here, 0.0000032, I can see that I have a number less than 1, like this number. That number is less than 1. So that tells me right away my exponent at the end has to be negative. It's just something to keep track of. And then again, we'll move the decimal to make a coefficient between 1 and 10. So again, if I move the decimal this way, I'm getting further away from that range of 1 to 10. I'm getting a like smaller and smaller, less and less and less than 1. That's not going to help me. So I need to move it in the other direction. And I just keep moving it until I've made a number between 1 and 10. So like when I get to here, I've made 0.032. That's not between 1 and 10. So I move it again. And that makes it 0.32. That's not a number between 1 and 10. So I move it one more time. And then I have 3.2 that is between 1 and 10. So 3.2 becomes my new coefficient. And then if I remember, it's got to be a negative exponent because I started with a number that was less than 1. But if I count, this time we moved it 6 times. So our exponent's specifically a -6. If we understand what scientific notation means when we look at it, that also means we can move from scientific notation back to standard notation. So for instance, 5.21236 times 10 to the 5th, writing that in standard notation. When we see this number, we have to decide which way am I going to move the decimal. And that's going to be based on, again, if the exponent's positive or if the exponent's negative. When the exponent's positive, we want to make the coefficient be a number bigger than 1. When the exponent's negative, we want to make a coefficient that will be smaller than 1. So for an exponent of +5, we want to make this coefficient larger. And again, if you think about it, moving it this way would make it smaller. 5 would become 0.5, and then it would become 0.05. That would make it smaller, which doesn't fit with a positive exponent that we had here. So instead, we're going to move it the other way, moving it here. And because the exponent was 5, we're going to move it 5 times. So that's 1, 2, 3, 4, 5. 5 movements. Then our new decimal point comes over here, and we have 521,236, which is 521,236 with an implied decimal point on the end there. So here are some practice problems for you to try. I would prefer you to pause the video before you actually do those, and then come back and watch the video to check with me. So go ahead and pause the video right now to try that yourself. And when I have you playing the video again after you tried it yourself, I'll point out that any of these that are asking for scientific notation, there's got to be a ×10 in there. So you might as well write that part before you forget it. And you can also decide if your exponents are going to be positive or negative, depending on if the standard notation number is greater than 1 or less than 1. If it's greater than 1, you need a positive exponent. You don't actually have to write the plus sign. I just like to do that so I don't forget. But you can leave the plus sign off if you want. But for the ones that are less than 1, you absolutely have to include that negative sign. But I like to just write it in right away so I don't forget about it. Once you know if the exponent is going to be greater than or less than, or excuse me, if the exponent is going to be positive or negative based on the original number being greater than or less than 1, then you can start moving the decimal point. When I look at this top problem, I know I need to make a coefficient greater than 1. So if I take that implied decimal point that's right here, if I moved it this way, then I'm not going to get something between 1 and 10 because I'm going to be getting bigger and bigger and bigger, further and further away from 1 and 10. So I need to move it the other way. And I'll just keep moving it until, like, if I stop there, that would be 880. That's not between 1 and 10. If I stop there, that'll be 88. That's not between 1 and 10. But if I go one more, 8.8 is between 1 and 10. So that's what my new coefficient should be. And then I count how many times I moved it. And I moved it 9 times. Again, that's a positive exponent because our starting number was greater than 1. You don't have to put the plus sign in there, but again, on a personal level, because I want to make sure I don't forget to check if it should be positive or negative, I personally like to write it in there just so I, like, future me knows that past me thought about it. Okay, for the next one, similarly, we think about moving our decimal to make a number between 1 and 10, and we count how many times we moved it. And because that starting number was less than 1, we have a negative exponent there. Again, for all of these, we're just checking how to get it between 1 and 10, and then we're counting how many times we moved it, and then we're deciding positive or negative exponent based on what the starting number was. For the ones going backwards, we're going to take a look at the exponent first, because if the exponent's negative, that tells me to make it smaller, versus if the exponent's positive, that tells me to make it bigger. So 6.8402, if I move it this way, 6.8 becomes 68, or move it again, 6.8 becomes 684. That's making it bigger. That's not what we want to do when the exponent's negative. So that's the wrong way to move it. I need to move it this way. 6 becomes 0.6. I have to move it 2 times because that is a -2 for the exponent. So I'll move it 1 more time. And then for that empty spot there, you just fill it in with a 0. So this becomes 0.068402. And similarly, for the next problem, if I were moving it in the same direction for the second problem that I moved in the first problem, I'd be making it smaller. 4 becomes 0.4, it becomes 0.04, 0.004. But since this one had a positive exponent, I actually want to make it bigger. So this time I want to go in the other direction. And I got to move it 8 times because there's an exponent of 8. So 1, 2, 3, 4, 5, 6, 7, 8. You fill in all the rest with zeros. Did I count that right? Yeah, okay. And that becomes 400 million. Similar thing happens for the bottom two. You want to check yourself. There you go. Moving on to the next page. There are many ways to enter quantities and scientific notation into your calculator. We're going to use a method that replaces this times 10 with a caret with a capital E instead. So the way this works is on a graphing calculator. If you have a TI-83 or a TI-84, then there's a special place where you can type to get this E, and then it ends up being less to type, and you don't have to worry about parentheses if you type it this way. So I know this is a little more abstract because you may not have a graphing calculator at home if you're watching this video from home, but you can always rewatch this video once you do have access to a graphing calculator if you need to. And when it comes time to actually type out this math, if you don't have a graphing calculator, I will also show you some other ways to do this on your Chromebook. It's not a big deal, don't worry about it, but just real quick, I want to walk you through doing it on your calculator if you have a TI-83 or a TI-84. Basically, you hit the second button, and then you hit the comma. If you look right up here, right above the comma, second comma gets that double E, which that stands for engineering exponent, which is basically, this is how engineers tend to write scientific notation because it's faster, and engineers as a group tend to be about speed and efficiency. It's sort of like their thing. So engineers like pioneered, I guess, using the E this way. So they get it named after them. Lucky engineers. So basically what ends up happening when you use your calculator this way is that while you would write on your paper 8.73 times 10 to the -4th, in your calculator, it would look like this, where that E for exponent is standing in for the times and for the 10 and for that little like caret button. You know what button I'm talking about, right? When I say caret, this thing, that button, we don't need to type that button if we're using E. You don't need that button to use E. In fact, you should not use those together. It will screw up everything. So you don't need to type times or 10 or that little caret button if you're using the E instead. Those mean the same thing as each other. And your calculator will actually always return scientific notation looking like this with the E, so you have to know how to read it anyway. But if you type like this, 8.3 or 8.73 times 10 to the negative 4, if you type it like that, then while typing it like that will give you the same answer back, it will also mean that if you type it like that, you have to use parentheses all the time when we start multiplying and dividing scientific notation, and that's going to be a pain in your butt. So I'm trying to save you from that. Please don't type it like that. I just want to save you some grief, okay? Use the E. And again, you have to be careful if you're using the E, definitely do not use the time 10 at the same time, because that actually will change your answer. Because you're multiplying by 10 an extra time, basically. So something to keep an eye out for. In this class, we're going to always use 2 decimal places when we round. We round to the hundredths place. So there's a slight exception that probably won't come up very often, but if the first 2 decimal places are zeros, we round to the next place. So like here, the hundredths place is a 0, so we're not going to round there. We just round to whatever's next. Remember, if you're rounding to the hundredths place, you look at the next digit, which is the thousandths place, and then you choose to round up or down based on if the thousandths place is between 0 and 4 or 5 and 9. So like 1.43, if I'm rounding this to the hundredths place, the thousandths place has a 2 next to it that tells me to round down, and it stays 1.43. But if I've got 1.43 and the thousandths place is a 5, that 5 tells me to round up, and it becomes 1.44. So that's just a note on rounding. In scientific notation, you round the coefficient and then you write times 10 to the exponent after the rounded number. So 5.3888888, blah, blah, blah. We look at the thousandths place, which tells us to round that up to 5.39. And then we check that e to the negative 26 at the end is telling us that the exponent of 10 is negative 26. So it's going to be times 10 with an exponent of negative 26. The e stands for exponent. So the whole thing, when you put it together, 5.39 times 10 to the negative 26. There are some practice problems here. If you have a graphing calculator, you can just hop to it. With these, if you do not, then let me show you how to use my good friend Google Sheets to do that for you. Okay. You can type scientific notation into Google Sheets by literally just typing an E. So if you look at the first problem on that page of practice problems, it says 4.7 times 10 to the negative 4. I'm going to just type E negative 4, where E is my exponent of 10 was negative 4. And then that's supposed to be divided by 7.1 times 10 to the third. Again, I'll just type 7.1 E3. That is, E is for exponent, 7.1 times 10 with an exponent of 3. This is what Sheets will make it look like. It'll always make them 2 digits. And then to solve that, if I hit the equal sign, and then I tell it to take this number and divide it, this number, bam, that's my answer right there, 6.62 E negative 8. That's all there is to it. Now, I will point out that there are some problems on here that it may not actually automatically give you scientific notation back when you first put it into your calculator, but the directions to say that all of your answers need to be in scientific notation. So if your calculator gives you back a number that's not in scientific notation, you need to move the decimal yourself and put it in scientific notation yourself. So like if it gives you like 1, 2, 3, 4, I need you to put that into scientific notation by moving that decimal point. So that this is your final correct answer. Even though these are technically the same number as each other, like these are equal, the whole point of this is to use scientific notation. So if your calculator gives you back a number that's not already in scientific notation, you got to change it to scientific notation yourself. And that is all I wanted to say about scientific notation for now.